Okay, another topic that is interesting in this context is this idea of network ensembles. So, a network, we have said, it is nothing more than a function y is equal f of x. So, uh, and depending, we train the weights on some particular choice of input data, input pairs of x and y's. So what if we train different networks? All the functions should be somehow similar, and because we know that we have these problems of overfitting uh, by doing multiple learnings, we might have a better prediction. So it is like trying to predict multiple times the y, and the average of all those y's should be closer to the ground truth. So here it is illustrated, this idea. I didn't find a beautiful picture with networks. Here there are decision trees, but the idea is the same. So let's say that you have some input data and you have 20,000 samples. Then you separate into training and test, and the training, now you construct multiple versions of that training by bootstrapping. So all these subsets, they will have 12,800 samples, but some of them will be repeated. That is the definition of bootstrap. And then once you have these subsets, you train a model on each one of them, and so these outputs will be the y. So now you have multiple y's, and you have to combine all these y's into a single one, so that the collective behavior will be your estimate of y. Okay, so you can do that with neural networks. So you have multiple inputs, and then you train multiple networks on it, and how you choose which network sees which data. It is very flexible. So sometimes you restrict the data that the network sees. Some other times, because of the random initialization, you know that it will learn a different function. And then once you have the different outputs, you have to combine all these outputs into a single output. This will be the combined output of the ensemble. So it makes a lot of sense. And also you can be very creative. There is another way of combining the data, that is this called deep stacked ensemble. So let's say that you have a set of training data. With this training data, you construct a model that is, or you build k models that not all of them sees the same information. So you have kind of different versions of y, and now you construct a new network. This new network will see all the input data plus the predictions of each one of these k models. So the input will not only be the input data, but also what is the opinion of all these experts on a particular row, on a particular sample. And then somehow you have to, so this is a basic model. You can stack this model as much as you like, so you can nest it, and so now this is a new expert that might participate in this process with other experts. And you can also combine it in this way. So somehow you have the input goes into the different networks, and each one is given an output, and then there is a gating network that decides which one of these is correct, so which one of these to let it pass. So given this input, somehow this network learns, oh, I know that for this kind of images, these classifier has become an expert, while these classifiers they are not so good. And then this combination is non-linear, so it is not just voting or whatever, it is just selecting one of the experts, and this way of selecting can also be very creative. And then this will be your output. So you can train everything at the same time, or you can train each one independently and then train the gating network independently. So again, you can be very creative. This idea also is interesting. Not all the experts need to be completely different, in the sense that some of the networks may have a shared base and then a particularization. So maybe the recognition of the visual features you can take from an already pre-trained network, and then you can add extra layers to each one of the experts. Or again, you can be very creative about this. And this would be it. So see you in the next video.